Today we're going to look at combustion reactions and how we write the equations for those types of reactions. When we were in Chem 1 and we looked at combustion reactions, we really only looked at the combustion of carbon, hydrogen, and oxygen containing substances. So our products were always carbon dioxide and water, carbon dioxide and water. The only time we ever had anything different was if it was an incomplete combustion reaction, and then we would say that it formed carbon monoxide and water. However, the true definition of a combustion reaction is that you get oxygen compounds, you get oxides out of all of the substances that are in the fuel. So commonly carbon is in the fuel, so it's going to have CO2 as one of the products and hydrogen also, so H2O. Another one of the common substances in a fuel is sulfur, and as you notice, the sulfur, when it combusts, is going to form the SO2, sulfur dioxide compound. And any other element that's in that particular compound is going to form that's in the fuel is going to form an oxide as well. So let's look at some examples. First, we have carbon disulfide vapor, so carbon with two sulfurs, and it's burned in excess oxygen. So we're going to add oxygen to it. That's one of the most common things that people forget is to add that oxygen in that we need when it's burning. So carbon disulfide plus oxygen, we're going to get an oxide from both of the elements in the fuel. So carbon, we've already established that carbon forms CO2, and we've already established that the sulfur is going to form SO2 when it reacts. Now, when we balance it then, we're going to need a 2. We need those sulfurs to balance. And when we do that, that's going to give us 4 oxygens from the SO2 and 2 more, there's 6 oxygens. So we're going to need a 3 in front of this oxygen in order to balance that reaction. The next one is involving the combustion of silicon tetrahydride. So we look at that silicon tetrahydride and we see that it tells us we're supposed to react it with oxygen. So we react it with O2 and show that adding in as a reactant. We're going to get an oxide of both elements. The water is an obvious one from the hydrogen in the fuel, so we're going to get water from this. We're also going to get an oxide of silicon. Now, silicon, you might not know what its charge or oxidation state is, but notice that it is a +4 state with the SiO4 over here. And a very common compound formed is going to be the SiO2, silicon dioxide, which is what we think of as quartz or sand. So that's going to be the other substance that is formed in this reaction. So when we balance this, it looks like we need to balance the hydrogens first by putting a 2 in front of the water to get our 4 hydrogens on both sides. And then now we have 4 oxygens on the right, so we're going to need to balance that out on the left. So there's our reaction for the silicon tetrahydride reacting. So our next example then says that ethanol is burned completely in air. And this is where we need our nomenclature of hydrocarbons to know what the formula for ethanol is. Since it ends in -ol, we know it's an alcohol. Recall the formula for alcohols, CnH2n plus 1, and then tack on OH at the end. So F is the prefix meaning 2, so that's going to give us C2, H2n plus 1, 2n is 4 plus 1 is 5, tack on the OH in the end. And we're going to burn that completely in air. Now when they do that, they say that a lot on the AP test, that means they're wanting to show that you're reacting it with oxygen. I know there's other things in air, but it's going to burn in oxygen. So when we react this, we're going to get oxides of the elements in the fuel. And since this is a carbon, hydrogen, oxygen compound, we're going to go back to classic Chem 1, carbon dioxide plus water when we form this. So now when we balance it, looks like we're going to need a 2 in front of the carbons to balance them. And to balance the hydrogens, we've got 6 from our alcohol, so we're going to need 3 over here. That's going to give us 2 times 2 of 4 oxygens from the CO2 and 3 from H2O. That's 7 oxygens. Now, at first glance, we might not think this is going to work, but don't forget we've got this oxygen over here. So if I put a 3 in front of that oxygen, we're going to have 6 plus the 1 from ethanol gives us our 7 oxygens to balance this compound. So this, I've got a lot of writing around this, so I'm going to box this so that you can see that this is the final answer for that particular reaction.